Probably I will not use too many words. Yeah. So please, I invite you to look at the images. Images that actually cover a few projects I have done. So it's only realized projects I'm showing. It's not ambitions, it's not aspirations, it's what I have done. And it's green in a very different way than many people are thinking of green. It's also engineering in a different way that many people think of engineering. So it's very much design driven. Let me start here. 25 years ago, we were thinking about fusing art and architecture. Is that green? Is that engineering? Well, I can tell you it has a lot of challenges that lead to green and lead to engineering. I will show you in the projects after this. So what you see here is a building that is both a sculpture and a piece of architecture. So it's two things in one go. So you pay for one, you get two. That is the ultimate green factor, because you have two things for one price. It has structural components to it. You can think of a regular structure holding up that piece of art, but you can also think of a structure that is actually synchronized with that piece of art, and that challenges engineering. So basically, by fusing art and architecture, we challenge engineering. That's another positive factor, and you will see the results of that later. We used modern technologies. In that time already, we used 3D milling, etc. So the first example I will show you of realized projects is this garbage transfer station realized in the Netherlands. So another green aspect here I want to discuss with you is having a very loose envelope. So don't follow the program exactly, but be more generous. So the generosity pays off in terms of being green and efficient. So this is the building that's actually a box, but then shaped in a streamlined style as to give space to everything, give extra space. So we give this surplus of space that can be used in many different ways later. So making a loose skin is a form of efficiency, actually. It's not efficient to be exactly following the program. It's much more efficient in the end to be much more generous about it. It also started a discussion about building using variable sections, which is no longer repetition of the same, but actually it's going away from the standard and go to the non-standard, where every component that the building consists of is unique. That allows us to make unique building bodies, as I call them, that have a very strong expression. So you see other different green aspects here that are worth noting. For example, this is for natural ventilation and for natural light to come in. So we use less energy for the light. We use much less energy for actually the ventilation. So that's all incorporated in that thing. So we do more things in one go. And that pays off. We designed an entrance here for the chauffeurs. It looks very luxurious. So although these are the workers, are the chauffeurs, the drivers, they come in here and they are treated very well. I think, can you call it green? I think it's an aspect of social behavior that is very positive and will lead to much greener behavior. By the way, it's a garbage transfer station, so it's about recycling the garbage. Okay, the next subject I want to discuss is this one, unibody. to actually design a building not as loose components, but as a very well integrated whole, pays off again in terms of energy, in terms of efficiency, robustness, and with sustainability. I start with a visionary design, defining the main drivers for the geometry in a very simple way, working with reference points to actually define all the details. It results in this body. It's no longer a building that is made from columns and beams, etc. No, it's unified. And by this unification, you get a lot of profit. Because everything is related to each other in a very integrated way, and you don't do double things anymore. It's very efficient. It looks like this in the building stage. It looks like this. Bringing the big components as prefabricated to the building site. I'm not sure where I should. And it looks like this in the interior when finished. So what you see is much more of an art project than an architectural project. Yet it challenges engineering to the max to make things like this. And we use very normal materials. We use normal technologies, but we use it in a different way because we think like a designer. We don't think like an engineer, we think like a designer. And we challenge materials to actually behave in a different way, like you can use flat material and you can make torsions to it if you use the properties of materials, which is again, I think, a very green aspect. So don't use the materials what they are intended for, but try to find out how you can actually play with that and make the max out of it. I'm not sure where I should be pointing at. More interior. That was a section I want to show you. So basically, steel structure, space in between, cladding, insulation, heavily insulated. So I think it's the best insulated building in the world. I mean, it's just one body with a very fat insulating skin. It uses almost no energy. It sits like a sculpture on the rocks. Doors are cut out of that body. So we don't do doors from a catalog, no, it's part of the building itself, part of the system. It's the unification of everything. And the end result is a sculpture. A big piece of sculpture is both art and architecture. The theme I'm discussing here is the theme of Second Life. You will find it in the end of this series of slides. But first, I'm a designer, so I'm always talking about design issues. Fault lines like these that appear, become sharper, disappear again. Reflect the light up there and reflect the ground down there to make it look more elegant. So these are technologies that are used in techniques that are used in the automotive industry and we can use in architecture in many different aspects. For example, in designing this pavilion, using same attitude for sharp fault lines, fading in, fading out, and then translating it via computer programs and a building system into a very logical, highly integrated system that is parametric and is connected to digital production. So everything is already in the first design stage is already known how to fabricate. So I don't go in details, but everything you see here is actually developed in the designer office, not in an engineering office. So we bring back the engineering to the architectural office. This is the complete structure, test model, and this is how we did it. Just describing each individual component precisely. So this is not technology of now, this was technology of 2002, 15 years ago. So what you see now, and people are promoting this with building information modeling, it's basically old school. It's something we did years ago. And many architects should have done that actually, but they didn't. And because they didn't, the building industry is still very inefficient. It's still very backward. And it relies on traditional building technologies like casting concrete in situ, etc. Basically, my message is very clear. Just stop doing that and start thinking again how to build in a proper way according to a design to production method. This is all technology. It's plasma cutting. Building the structure in the workshop first, make a good definition of all components, and then dry assembly on site. I'm not sure you're listening to this, or you have another discussion maybe. You just tell me. Otherwise, I join your discussion, might be more interesting. So, is it art or is it architecture? That's the question here. It has a door. The door is part of the structure again, so it must be architecture. But it's also a vehicle. Like this Mercedes-Benz from the 50s is a vehicle, and it shares the same aspects. It's a body, and the door is a cutting out of the body. It has a streamlined shape. It has a vector. It wants to go places. That's exactly what I want to do with buildings. So it's not building as usual, as you can see. It's just rethinking building from a design perspective and an engineering perspective, because it's a fusion of art and engineering to build something completely new that is very green, because it's so efficient. It uses very little energy in both the design part and the construction part. So will it get points in LEED? Will it get points in other rating systems? No, I don't think it will get any points. Yet it's greener than most buildings that get maximum points. So how can this be? How is this possible that the LEED actually completely bypasses techniques and technologies that are here to see and that are actually at hand for years already? So it's so much driven by traditional building processes that they actually tend to forget what is available and how you could change it. So in my career, things were getting bigger and bigger, but I was applying exactly the same technologies on larger scales. So this is an acoustic barrier. In that barrier is embedded a cockpit building. It's a showroom, a car showroom. So it's exactly the same as I said in the beginning. You do two things at the same time. It's an acoustic barrier, but it's also a showroom. So building this part actually was a cost reduction for the community to not having to build this part of the acoustic barrier. So it's an enormous cost saving. At the other hand, this man is now in front row and can show his product as close as possible to the passers-by, to the highway users. So you have the best of two worlds. the way it's produced, it's completely scripted. It's another way of dealing with green in the design and engineering process, completely scripted, meaning that we didn't make drawings, no, we scripted. Yeah? So you describe what all the components have to be, you describe all the relations between all the constituting components, and you make it. Each has an explicit identity. We have 40,000 unique IDs. You put them together with very little people. It's not a big team, so no need for many unskilled workers at all. You only need a very small team to assemble buildings like these. So it's very cost effective. You don't have to provide for all the housing of all the workers because it's only a very small team that's doing that. So this transparency and this leanness, because that's the key word, it's lean rather than green, can save society a lot of money and actually give extra value to the built environment. This is the interior of the showroom and the exterior again. Two more projects showing more of the same attitude, and it's everything I've said before is true for what is done in these projects. What we also did.
Every human being has a basic instinct to help each other out.
The building was
if a hiker gets lost in the mountains, people coordinate a search.
In the movie The Martian,
if an earthquake levels the city, people all over the world send emergency supplies. This instinct is found in every culture, without exception.
So I just run the movie a little bit that you see one shot that you can see it's shot inside the building I have done in Budapest.
The storm had escalated to severe, and we had no choice but to abort the mission. But during the evacuation, astronaut Mark Watney was killed.
This was shot in, this is in Wadi Rum in Jordan, by the way. This is where the movie was made.
I'm entering this log for the record. This is Mark Watney, and I'm still alive. Obviously. I have no way
This
to
is
contact
also
myself
inside
or my crewmates.
the building.
Even if I could, it would take 4 years.
In this building. So the last shot was shot here, the other shot was from here and looking into the atrium between the two old heritage buildings where this new shape erupts from. And this is the big space where all the monitors were actually erected, and this is the view into that atrium space. It's very well used. Again, a lot of double functions combined. It's not only a corridor, you can also use it for other functions, etc. So a lot of that thinking of double use of the same space has been implemented here. This is for you to understand how it works. This curves driving the system, populating the surfaces, reference points that talk to each other like the swarms in a bird. So this is not just metaphorical, it's exactly how it works. Yeah, all these points are related to each other and establish a parametric relationship. And by doing that, you can make complex shapes like this for exactly the same amount of money for a very simple rectangular box. So this is a message that cannot be underestimated. It's also very green. It's also very efficient, cost-wise especially, but also cultural-wise. But why is it not applied on a larger scale? That would be a very good question, because I made some of the cockpit building I made 10 years ago, the Balna 7 years, and this building in Abu Dhabi 5 years ago. The building industry is still not ready for it, and that is so disappointing. So why doesn't someone stand up, preferably in Qatar, and just say, let's do it in this more efficient way. Let's just do it. Bypass a lot of traditional processes and connect the designer to the production, to the computer numerical controlled production, establish a strong relationship between all the constituting components, make the components in the factory, assemble them on site with few people. I mean, these people are doing nothing. There are only a few people that actually work here because you don't need them. You only need a few cranes and a few people to assemble this. The building almost self-erects. You fix the components together and it builds itself. You don't need scaffolding. It's its own scaffold. It's another green aspect. No scaffolding needed. This is the flexibility of the plan. It's a very simple core, and this is how the envelope, the loose envelope again, behaves around that central core. Windows looking down, looking up, gives you a great view of the environment. At the same time, reducing the amount of glass drastically. We only have, I think, not even 30% of glass in this facade. So it's much more efficient than any of the buildings around. So I end up with this overview. We do the fusion of different things together. If you overlap them, it's a very green aspect. If you have a loose envelope, it's a very green aspect. If you integrated all the components into a unibody, it helps you enormously in cost savings and process savings. Then, I didn't discuss it, but actually the building I showed you, that small pavilion, was rebuilt again, so it had a second life. So because it's dry assembly, I'm finished. Because it's dry assembly, you can take it apart and you can rebuild it again. So we did that. Fighter factory is the same as parametric design to robotic production. Make sure that whatever you design as an architect, you relate directly to how it is produced, and digitally produced, I mean, not manually. So no work at the building site, but just assembly. Connected working groups is referring to how we worked with the Balna Budapest. We had an office in Rotterdam, in Budapest, and we were working on the same project. So you don't need to be at the same place to work on the same project. Yeah, using the new digital technologies of exchange and working groups in Revit in this case. And then that shows, that's actually true for everything. Parametric connectivity, make sure that every single building component, like the swarm, like the birds in the swarm, every single building component has a dynamic relationship with its immediate neighbors. That's basically the theory behind it. So if you think about that and apply it to the building industry, the future looks bright. Thank you very much.